Hello, good morning. So maybe good afternoon for you guys. So because of the COVID situation, we have to do the online course. So here is the first course after a short pause for a while. So let's start here. So we resume with the lecture 8 and let's see what is the content. So maybe a little bit background. Maybe you see already this slide in the very first lectures, and you already learned this one. So to say, we already finished the statics. So now we are entering this regions, the new one, which is the dynamics. So what is the difference between the static and dynamics? So first, as you may know, the static is you have no accelerations, so there is no movements, everything is in equilibriums, so all the force is in equilibriums. So to say is corresponding to the Newton laws, the very first laws. So sigma F equal to 0. And also we also use the third law also in some reaction that the reaction force equal to the actions. So we use that for example, for the support force. But then now we are focusing on dynamics. What is the dynamics? So the dynamic is the motion of the bodies, as you can see here, and the acceleration is not 0 anymore. So let's get to the topics. So first we will learn about the kinematics of the particles. So as you may remember, the particles, normally we have the body, for example, ourselves as a human bodies, but we simplify the body into simple particles. So to say, for example, instead of we written, maybe I'm changing the color of the pen. If we have a humans, and instead of written as this whole human bodies, we are focusing on only the single point. We say this single point is representing the body of the humans, for example. So what is the dynamics? This is just the introductions. So the dynamic, you will have two important terms. First one is the kinematics. This kinematic is, as you may see, maybe I highlighted, the study of the geometry of the motions. So this related to displacement, velocity, acceleration, and time, without the reference to cause the motions. For example, when we have a boy, again, when we have a boy standing here, we say he moved from one location to another locations. Okay, for example, by 1 seconds, we only interested in the displacement, which is maybe 5 meters, and we interested in velocity. In this case, velocity is what? Is 5 meter per second. Okay, but acceleration, in this case, we are the information is not enough. But anyway, we interested in only the movements of the particles or the bodies without any reference of the cause of motion. For example, we are not interested in which force causing this object move to the another location. We are not interested in. So kinematic is only the movement, no force, no energies. Okay, then we have another terms. Here we have kinetics. So the kinetics is the study of the relation existing between the force acting on the body and the mass of the body and the motion of the bodies. So instead of interested in only kinematics, which is only displacement, velocity, acceleration, and time, now we are interested in also the relation between the body itself to the mass or to the motion of the body, for example accelerations. So in this case, for example, F equal to ma. So this is kinetics because we have force, we have mass, and in relation with the acceleration, for example. Okay, so here the pictures here of the aircraft is just showing you how the force is related to, for example, accelerations, because there is some dragging force, for example, that dragging this plane back, so means it reduce the acceleration of this plane. And there is thrust force, which is, for example, the jet. And also there's a force lift, otherwise how can the plane is flying away. So okay, so I think it's enough for the informations. Next, so introduction of the particle kinetic including. So first, for the kinetic of the particles, maybe this word also important. First one is rectilinear motions. So this one is position, velocity, and acceleration of the particle as it moves along the straight line. And curvilinear motions, position, velocity, acceleration of the particle as it moves as a curve in 2 or 3 dimensions. For example, here, as you can see, here is a train and the movement is here in these directions, so it's only in the line. For example, when you walk on the walkway, you walk in the straight line, it means it can call rectilinear motions. But for example, if you walk like a how to say, if you walk like this, for example, now we call it curvilinear motions. Okay, so there's 2 kind of motion here. So next, we are focusing on only the rectilinear motions. So particle is moving along the straight line. For example, here is our original point, okay, and here we move to the next point. So this is the next point, we call it P, and we say in each scaling box is 1 meters, means we move from original to the P by 5 meters. And also rectilinear motion also have a positions, negative or positive. You walk forward or you walk backwards. So here we say it's a positive, and here we say it's a negative. Okay, so the motion of the particles, the position of the coordinate for the particle is known for values of time. Here it's just said that there is also relation between the displacement and times. Okay, so here you can see that there is no time relations, but here we say it's a motion, so it has to be position coordinate correlated with the time. And how do we read this? For example, you yourself standing here and you have a shop, or we can call it home, your home, and the distance here is 32 meters from yourself and home. If the graph below is the position coordination with the time of yourself. So when will you reach home? What is the time that you spend from walking from the original positions, so position 0, to your house? At you reach in the graph means it's 4 seconds, because you're spending time from 0 here, walking along until 4 seconds, then you reach 32 meter distance. So you spend 4 seconds forward. And how much you spend time for walking backward? So you walk back to the original place. So if you read the graph here, I would say this is a backward. So when you walk backwards, so you spend only 2 seconds. So in total you walk back and forth in 6 seconds. Is it understandable? So next we will talk about the rectilinear motions, but this one is for velocity. Okay, so what does it mean, velocity? So in terms of mathematics, the velocity is the position change in specific time. For example, here you can see that the velocity is delta x, mean, for example, x at time 2 minus x time 1, and then over t time 2 over t time 1. Okay, means this one means is the displacement change over time. Okay, so mean when you stand here in t equal to 1, for example, if t equal to 0 seconds, are you going forward or are you going backward for the next seconds? So if you are going forward, for example, in the next seconds, you are in t equal to 1 seconds, your distance is now x equal to 1 meters, and this is x equal to 0 meters, means your velocity is what? 1 meter per second. Okay, right? But in terms of instantaneous velocities, means the times here is really important terms. The delta t is really close to 0. Okay, so now we can also use the calculus to help calculating of these formulas. And as I mentioned before, if you're standing here in the first positions, if you move forward in the positive sign, then your velocity is plus, okay, more than 0. And for example, if you move backward here, negative sign, means velocity is also negative. Right? Okay, so if you remember the graph last time, I think there is a graph last time as x, m, and then there is a t, s, and then the graph is like this. If you remember, this is 32 meters as you reach your house, and then at 4 seconds, and here is 6 seconds. Now what we did here is we say this is the function for this x of t is 6t to 6t power of 2 minus t power of 3. This is the formula for this curve. And how do we find the velocity? So as you already see the terms here, okay, as I highlighted here, so the velocities is just the derivative of the positions, function of your position or displacements. Mean here you just derivative of this x, then you got this v, and then by this formula you can plot this curve. Okay, all right, then we go to the next point. Next is accelerations. So again here acceleration is similar relationship between velocity and displacement. You remember velocity and displacement? The velocity is just the change of positions in specific times. Also the same for accelerations. Acceleration is also the change of velocity in certain times. So what does it mean? When, for example, when accelerations, this is the original positions here, okay? For example, t equals to 0. And then if accelerations is more than 0, like this, means the next seconds, okay? Oops, my bad, this is not true. Okay, so here the next seconds, t equal to 1, t means times, we have more magnitude of the velocity, as you can see here. So we have more of velocity. That's it. So if acceleration is more than 0, mean you have more velocity in the next step, in the next second, or in the next milliseconds. What about negative? So I erase also the old one. If this is t0, okay, means it is time as the origins, and if the acceleration is more than 0, but here you can see the velocity is in negative, okay. I forget to mention here is the velocity in the first phase here is positive, so that's why when it is the next step, then velocity is getting more. But if the velocity in negative here, and if acceleration is positive, in the next seconds at t1, we will get less magnitude over the velocity, okay. And of course here also similar things. If you get acceleration of -1, then in next second you will get reductions of acceleration of velocity, sorry. Right, also here if you get negative velocity accelerations, you will get more magnitude of the velocity if the velocity is already in negative. Right, and here also the graph, how it is derived from. So same as previously, so we got this velocity functions of time, and then we just do the derivative of this function, and then we got this acceleration is equal to 12 minus 6t, and we can plot it here. And then if you overlay those displacement, velocity, and accelerations. You can see that those three is related to each others, right? For example, here at the positions of the velocity is how to say, velocity is starting to get negative. You can see that the slope of this acceleration, the slope of the displacement is going to reduce. Okay, and if, for example, if you integrating this area from accelerations from velocity here, you will get the 16 here. Okay, if you integrating velocity, you get the displacement. This is what I would like to say. And here, for example, if I really ask what is the displacement, velocity, and acceleration as t equal to time equal to 2 seconds, how do we find it? So you can just plug in those 2 seconds into the formula, and then you will get these results. Okay, or another way, you can take a look at the graph, but I would say in realities or in the assignment or problems, we will get mostly the function of displacement, velocity, and accelerations. You can just plug in those 2 seconds into the formula, and then you get those results, right? So also one note is also really important. So note that Vmax occurs when acceleration is equal to 0. Okay, for example, here we know that acceleration is equal to 0 here, means from this point the velocity is starting to decrease, mean at this point we get the highest, or Vmax, right here when we get acceleration equal to 0, because this one will be also asked in the problems to find the Mach velocity, for example. Okay, then also what are the velocities, displacement, and acceleration as time equal to 4. You can just plug in those, and then you get this formula, right? Next is determinations of the motion of particles. So we oftenly, this is now very interesting, we oftenly determines the acceleration from the force applied. For example, if we have an object here, then you have a human pushing this, and this is induce the force. Okay, and then of course there will be a friction force by the roughness of the surface here. You know that when you dragging your chair on the rough surface on the cement is harder than moving the chair on the ice, so this means of the friction force, also depending on friction coefficient. And normally we say sigma f equal to ma. So to say, we oftenly use the force applied to determine the accelerations. For example, in this case, a equal to F minus friction force over m, for example. Okay, and generally we have 3 classes of motions. We have acceleration given by the time of functions, the function of times, acceleration given by the function of positions, acceleration given by the function of velocities, right? But can you think of physical example when the force is function of positions or even velocity? So first one, the spring. You know that when we compress the spring, for example, here is the L0 for the spring, means the spring is relaxed, there is no force applied, you just put the spring on the tables, and then when you compress the spring to L1, you will get the spring force to your hand, okay, from both sides. If you compress it from both sides, then of course you will get the spring force equally from both sides, right? So this means also the force, or so to say the acceleration, is depending on the positions of those springs. And what about velocity? So you can see the sonic booms when we traveling really fast, and then we have a sonic boom there, then there is a drag force causing by those velocity if you traveling too fast, right? And here is the acceleration as a function of time, position, and velocity. So to say, for example, here is the kinematic relationships of acceleration and velocity. So of course the velocity is the acceleration is in differentiation of the velocity, okay? And if we say it's integration, of course the integration of the acceleration equal to the velocity on the right side. So to say also apply to the acceleration in terms of position and velocity as you have been seen in this table, right? Okay, so for the first samples, let's read it through. We have the ball tossed, so we're throwing the ball by the velocity of 10 milliseconds vertically, and we throw it from the window 20 meters above the ground. The question is the velocity and elevation above the ground at time t. So second is the highest elevations reached by the ball and corresponding to the time. So we would like to know how far the ball can traveling upwards, the highest peak, the highest height, and what is the time at that peak. And the lastly is the time when the ball hit the ground corresponding to the velocity. Okay, so solutions. What do we have to do? First, we know already that the gravity is minus 9.81 meter per second square. I think you know this already, right? And it's in negative because when you're tossing the ball, the gravity try to dragging down the ball down, so velocity is reduced when the time pass by. So that's why the acceleration always negative for the gravitational force. And okay, so maybe let's do it. Can I do this? Okay, so let's start as the relationship. So we have, for example, we have the BC. Okay, so we have we use the white one. Sorry, let me have a look a little bit. I'm not sure how can I. Okay, got it. All right, so we have a ball. Tossing upwards. So we say velocity is 10 meters per second. And then we have a height from the ground is 20 meters. And then we also have the velocity of okay. So first questions, find Vt. So we would like to find the function of velocity in times. So we would like to find the relationship between the velocity and times, right? Then you know the relation between the acceleration and velocity. So what is that? So derivative of velocity is equal to accelerations, okay? And then your acceleration is 9.81 meter per second square. And when you do the integrations, okay, because you would like to get the velocity, so you do the integrations, you move this here, then you get dv equal to a, or so to say is already in a constant number, minus 9.81 dt, and then we say is derivative, right? Oh, so when we derivative this, then we derivative from v0 to vt, and then this is 0 to t, means we will have on this side vt minus v0 equal to minus 9.81, and integration of the constant is equal to t minus 0, then 0 we can cross it out, and then in the end you get vt equal to v0 minus 9.81 t, okay? And then here is your formula, so it's here is the units. So alright, so we say here is our here is our relationship for the velocity. If I write it in the graph, if you draw the graph, so here's the velocity, meter per seconds, and alright, I forgot one thing, and v0, you can see v0 here is 10, so you can say it's 10, okay? So at time 0, this is t seconds, at time vt equals to 0, how was it? Is it equal to 10 minus 0 equal to 10 meter per second? So at this point is equal to 10. And then you know already this is a linear equations. So actually the slope here, I would say the slope here is minus 9.81. All right. Okay. So next is, now we already found the velocity and elevation above the ground at time t. So we can just plug in any time into this formula, and then we will get the velocity as the outcome. And next is this one. Okay, the highest elevation reached by the ball and corresponding to the time. So 2, what is Smax, and what is T of Smax? Okay. So what is the Smax in this case? So we know already that you know that when we reach the max height, this is when we have the velocity at 0. Why? Because from this point onward, the velocity is negative, mean the height of the ball is reduced. So if I written here also the graph of, so maybe I should also written also yt. So here I would like to find also yt, or we could say, okay, I would say it's ymax, right? So it's ymax, so it's distance in y. And what is yt? This yt is equal to integrations of velocity, right? Okay, and if you integrating this, then so maybe we shouldn't, let me erase again. Okay, so you know already that dy over dx over dt is equal to velocity. So the differentiation of the time is equal to velocity, and the velocity is equal to 10 minus 9.81 t as above. Okay, and then when you would like to find the displacements, of course you have to do the integration again, integration of y, and then you say v dt, and we integrations from y0 to yt, and this is time t to time 0 to time t, and then in the end we will get yt minus y0 equal to, okay, equal to integration of this, then means we have 10t minus 9.81 t squared over 2. So the integration, I think you already learned in calculus, so I wouldn't repeat this again. Okay, and then in the end you get yt equal to y0 plus 10t minus 4.905 t squared. And so to say y0, we already know it from this one that the guys throw the ball at the beginning at the window falling from the height from the ground is 20 meters, so here is 20 meters plus 10t minus 4.905 t squared. Okay, and then now you already got the equations. So this is the equations from for the displacements, and all right, so as I told you, when we reach the max velocity we will have, so to find y max, this to find y max, t of y max is when v of time equal to 0 seconds. Okay, so means we will use this Vt equal to 0. Oh, sorry, so my mistakes, my bad here. So when we reach y max is when Vt is equal to 0. Okay, so then Vt is equal to 10 minus 9.81 t, and then everything is equal to 0, means t is equal to 10 over 9.81, and then in the end it's equal to 1.019 seconds. And then here is the time when we have the maximum height, and then you can plug this time into the height formula, t equal to 1.019 seconds, and then 20 plus 10, 1.19 minus 4.905, and then when you solve this you get y equal to 25.1 meters. Okay, so means we have the y max. Here is the answer. This is the time, this is the height. Okay, so next, what did they ask again? The time when the ball hit the ground corresponding to the velocity. Okay, so we know that 3, what is the time when we have the ball hit the ground? So y t is equal to 0, right? So means the ball and the ground, it has 0 meters different is at the ball is at the 0 meters positions. Okay, and then what is the thing is he would like to find what is the time that the y is equal to 0. Okay, so we have the formula up there already. 20 plus 10t minus 4.905t squared, and then this is equal to 0. What does this call? This is quadratic equations. Okay, remember this? And then maybe you have seen this already. You can find the t by the formula like this. Okay, so sorry, then maybe I should. So here is the formula for quadratics. Is ax squared plus bx squared, no, not square, plus c equal to 0. To solve this, you can use x equal to minus b plus minus root square root b squared plus minus 4ac, and everything is over 2a. Okay, you can use this, and then when you use this formula to our equation, you will get t is equal to minus 16 plus minus root 16 squared minus 4.905, and then 7 okay. Nope, sorry, I put it in the wrong sense again. My bad. So t will equal to minus b, b is mean 10 here, so minus 10 plus minus square root 10 square minus 4ac is minus 4.905, and c is 20, and everything here is 2 minus 4.905. Let me check with the calculations. So I will find this term first. This term is square root 10 square plus or minus 4 multiplied by minus 4.05. And divided by 20. Okay. This is what I get. I get 21. Oh, no, 22.19. And then 10. I would say I will go for minus 10 and then minus 22.19 and divided by minus 2 multiplied by 4.905. Then you get one of the t is 3.28 second. Okay, and another t, if you calculate from this minus 10 and you plus 22.19, and then you divide it by this, then you get negative 1.243. And you know already, negative time is not possible. Means our answers is here. Okay. Alright, and also they also asked the time when the ball corresponding to velocity. Then we know time already. We just plug in this time into the velocity equations, and our velocity equations is 10 minus 9.81. So t equals to 3.28 seconds. 10 minus 9.81. Then in the end you will get minus 22.2 meter per second. Okay, so in the end, here's your answers. Here's the time that your ball will hit the ground, and here's the velocity when the ball hitting the ground. Okay.